right, these are the odd questions you have asked me to work. Number 1 is tangent theta plus cotangent theta equals secant theta, cosecant theta. What I did was I turned my tangent theta, cotangent theta into sine theta over cosine theta and cosine theta over sine theta. The common denominator is cosine theta, sine theta, and so since I multiplied the first one by a sine, I have to multiply the numerator by that sine, and since I multiplied the second one by a cosine, I multiply the numerator by a cosine, giving me sine squared theta plus cosine squared theta over cosine theta sine theta. Now, sine squared theta plus cosine squared theta is 1. That gives me 1 over cosine theta sine theta, which can be written as 1 over cosine theta times 1 over sine theta, giving me secant theta times cosecant theta. And this is the answer that I needed, so I'm through with that one. Number 3. It starts out tangent of x halves equal cosecant x cotangent x. And as you can tell, I cheated a little bit. I made this one 1 over sine x, and this one cosine x over sine x. Now, I sine x in the denominator, and that's important to me because when I come over here to the tangent x halves, I've got several choices, and I'm going to choose the one where sine is in the denominator. So that gives me 1 minus cosine x over sine x. Now, guys, I'm using the paper we're all supposed to have and be using. I chose it directly off of there. Now that lets me put 1 over sine x and negative cosine x over sine x. 1 over sine x is cosecant x. Cosine x over sine x is cotangent x. And I have what I was looking for. Number 5. We've got sine t plus 1 over cosine t equal 1 minus cosine t over sine t. One of these looks harder than the other. The problem is I've just got to work one side. So I've been working the left. I'm going to continue working the left. I'm going to do sine t over 1 plus cosine t. To make the denominator become sine t, I need to multiply by 1 minus cosine t. That's going to give me the 1 minus cosine squared t. In the numerator, I'm not going to multiply it out. There's going to be a little trick show up here in a minute, and I'm not going to need to multiply it out. As far as these two go, if you're having problems, you are more than welcome to come over here and show me that you multiplied these out. But by this point in time, I'm hoping that you guys remember the shortcut on this. That's positive, that's negative, that's positive, middle term goes away. Alright, that gives me 1 minus cosine squared t. Now the 1 minus cosine squared t is equal to sine squared t. So I have sine t times 1 minus cosine t over sine squared t. And since I have a sine in both the numerator and the denominator, I take 1 from each, which gives me 1 minus cosine t over sine t. And minus cosine t over sine t is where I was headed, so I'm through with that one. Now, I still don't think I did number 7, but here we go. Sine 2 theta equal to tangent theta over 1 plus tangent theta. My first inclination was that this is tangent of 2 theta, and then I got to looking. This is tangent of 2 theta. I think I'm going to go ahead and work on it and change my 1 plus squared theta to secant squared theta, and then I'm going to change everything to sine and cosines. If in doubt, go to sines and cosines. So I have 2 sine theta over cosine theta, and 1 over cosine squared theta. Cosine squared theta is my common denominator, so I multiply both of the numerator and the denominator by cosine squared theta. I get 2 sine theta, 1 of the cosines cancels, so I get 2 sine theta cosine theta. And in the denominator, I wind up with cosine squared theta over cosine squared theta, which is simply 1. If you look on your list, 2 sine theta cosine theta, a substitution for sine 2 theta. So I substituted it out. Number 9 is cotangent theta minus tangent theta equal to cosine squared theta minus 1 over sine theta cosine theta. Because I have a cotangent and a tangent on this side, I'm going to work them and see where it takes me. I have cotangent is cosine theta over sine theta minus sine theta over cosine theta. Common denominator again is sine theta cosine theta, which means I multiplied the first one by a cosine. So I get cosine squared theta in the numerator. Again, the common denominator is sine theta cosine theta, and that gives me a sine squared. Giving me cosine squared theta minus sine squared theta over sine theta cosine theta. Now I'm going to substitute out the sine squared theta for 1 minus cosine squared theta, which gives me cosine squared theta minus 1, minus the quantity 1 minus cosine squared theta. Okay. When I distribute, I get cosine squared theta minus 1 plus cosine squared theta over sine theta cosine theta. Now I get 2 of the cosine squared thetas minus 1, and then I have the sine theta cosine theta, and if we'll look back here, 2 cosine squared theta minus 1 over sine theta cosine theta is what we were supposed to get. Alright, again, number 11 is one of those that is a little bit tricky. On 11, I have sine x plus y over cosine x minus y equal cotangent x cotangent y, and 1 plus cotangent x cotangent y. First thing I do is I looked at that cotangent x cotangent y and thought, do I have a cotangent x plus y? And the problem is I have a plus in both of them. I can't have a plus in both of them. If it's a plus in the numerator, it has to be a minus in the denominator. So it has to be a cotangent of x plus y. So let's work on the other side. I know what sine x plus y is and cosine x plus y is. Sine x plus y is sine x cosine y, and sine y cosine x. Cosine of x minus y is cosine x cosine y. Use the opposite signs with plus, and then sine x sine y. Alright, I need cotangents. That means I need my signs in the denominator. For me to get the other half of this thing, I've got to have fractions in fractions. To get cotangents, I've got to have cosines over sines. So I'm simply going to multiply everything by that 1 over sine x sine y. When I get to the first one, I have sine x cosine y, and now I'm putting it over sine x sine y. The sine x's cancel, leaving me with cosine y over sine y. When I go to the next one, then I multiply here. I have sine y cosine x, and I have sine x sine y. The sine y's cancel, giving me cosine x over sine x. When I multiply in the denominator, nothing cancels for the first one, so I get cosine x cosine y over sine x sine y. When I go to sine x sine y over sine x sine y, I get 1. Okay, so when I start rewriting, cosine y over sine y is cotangent y. Now, I can look back over here, and I know I need the cotangent y, but I need it last, so I'm rearranging those. I'm switching the order. So cosine x over cosine y is cotangent x. I'm sorry, cosine x cosine sine x becomes cotangent x. Cosine y sine y becomes cotangent y. I put the 1 first, and then when I group the x's together here, cosine x over sine x is cotangent x. Cosine y over sine y is cotangent y. And so I have what I needed. Number 13 is sine theta plus tangent theta over 1 plus cosine theta equal tangent theta. All right, the sine theta side looks more complicated, so let's work on it. I'm going to do sine theta. Okay, unlike everybody else, I got lost, so let's turn these into sines and cosine thetas. I get sine theta plus sine theta over cosine theta plus 1 plus cosine theta in the denominator. Now, I need that fraction and a fraction to go away, so I'm going to multiply everybody by cosine theta. I also know that when I'm looking at tangent theta, I need a sine theta over a cosine theta. So if I'm going to multiply by cosine theta, I'm really not going to multiply it into the denominator, but I am the numerator. With the numerator, I get sine theta cosine theta, and then here, when I multiply it by the sine theta over cosine theta, the cosine thetas cancel, leaving me with just sine theta. So I have sine theta cosine theta plus sine theta over cosine theta times the quantity 1 plus cosine theta. When I factor sine out of the numerator, I get sine theta times the quantity cosine theta plus 1 over cosine theta times the quantity 1 plus cosine theta. Since the cosine theta plus 1 and the 1 plus cosine theta are the same, I can cancel those or reduce those out. That leaves me with sine theta over cosine theta, which is tangent of theta. Okay, that's all of them. I hope this helps you get started, and I will see you in class.